Hey guys, today we're going to be going over the very last lesson of Bio 30. It's a nice, easy lesson. It's all about succession. Okay, so like I said, this lesson is all about succession, which is essentially all of the different changes that a ecosystem or a habitat goes through after there's been some sort of disturbance. So we're going to look at essentially how different communities kind of build off of one another to get back to where that habitat was pre whatever that disturbance was. So for this, you're going to have to be able to define succession, define climax community, and define pioneer species. You're also going to have to be able to compare and contrast primary and secondary succession, describe the overall process of succession. You need to be able to identify what would cause primary succession compared to what would cause secondary succession. And then we're going to talk about how biodiversity, biomass, and productivity changes as we go through this process of succession. So succession is a gradual change in the community in a given area as it develops towards being stable. Immediately following a disturbance, that population may have been stable, but it's not anymore. And it's going to be undergoing a lot of changes for tens, if not hundreds of years as it moves back towards a stable community. The series of different plant types in that community as it develops is called the succession pathway, also called the SERE, S-E-R-E. The higher the soil quality in the area, the more different possible succession pathways there are. So the more different types of plant communities could be a part of that SERE. There are two different types of succession. There is primary succession and secondary succession. And depending on what caused the succession or what type of disturbance happened, that will determine which type of succession it is, whether it's primary or secondary. So like I said, succession always follows a disturbance or any large change that happens to the ecosystem. Those disturbances could be human activity like forestry or like paving a road, and anything that goes in and disturbs the community. It could just be walking through the forest can be a disturbance to a small community. Natural disasters, so things like floods, tsunamis, meteorite impacts, volcanoes, glaciers, all of those fall under kind of natural disasters. And then the last one could be diseases or parasites, specifically ones that affect plant life of some sort. If a previously dominant plant species is removed from the area, then you're definitely going to get succession happening. So like I said, that plant could be removed because we've cut it down for timber. It could be removed because it was infected by a parasite and it died, or it could have been wiped out by some sort of natural disaster. Like, again, like a fire or something. If the entire ecosystem has been altered, that could also be succession that's happening. Disturbances are essential in ecosystems. In order for ecosystems to be healthy, you want disturbances to be happening, of course, preferably natural disturbances as opposed to man-made ones. But in order to have a wide variety of tree and plant species in an area, disturbances are key. Disturbances are also needed to maintain higher species biodiversity. So if you don't have any disturbances and you just have a climax community, it will actually have quite low biodiversity. So primary succession is going to follow a type of disturbance that removes soil from the area. So it's not only going to remove the vegetation or the plants, it takes away the soil as well. So this type of disturbance is less common, and it takes a lot longer to recover from. Essentially, there will be no community at all in this ecosystem at the start of primary succession. So usually the type of disturbance that triggers primary succession would be like a volcanic eruption. So for instance, when Mount St. Helens erupted in the early 1980s, that was in the States for those of you that don't know, a massive area around that, well, a really large area was devastated in that it wiped out trees and it covered the area in ash. And then a closer area to the volcano itself would have been completely covered by the debris from the eruption, which included like rocks being blown out and magma and ash and all that kind of stuff. So that's one of the ways that we could trigger primary succession having to start. Another one is a retreating glacier. So because of climate change, we have a lot of glaciers that are retreating or melting right now. And as those glaciers melt, they're going to expose bare rock underneath or mineral soil, but it's not going to be any soil that can grow plants. And then the last one that usually results in primary succession is a human disturbance that exposes bare rock or mineral soil. So for example, like an open pit mine or something like that. When we have primary succession, the very first plant community to appear, which is called the pioneer species or the pioneer community, is going to be something that can live on just rocks. So we see some examples of this at the top here, things like lichen and mosses, which can grow on the rocks. So the pioneer community is the first thing that's going to colonize an area after a disturbance. If this is primary succession, lichen and moss will be that pioneer community, those pioneer species. They will colonize any rocky surfaces, and then they actually release chemicals that break down that rock into fine soil over a fairly long period of time. The rock is going to break down from those chemicals, as well as weathering and erosion and stuff like that as it's exposed to the elements. And so all of that will result in some soil being formed. As some of the lichen and moss die, that also adds some organic matter to the soil. And eventually, once enough soil has built up, small plants can start entering the community. And once that happens, we're no longer in the pioneer community, we've moved into the seer. If instead you have secondary succession, that means that the disturbance eliminated the dominant plant species, may have eliminated all vegetation, but you still have soil present. So that's following forest fires, landslides, floods, deforestation, those types of things. This type of succession can happen much, much more quickly than with primary succession because you don't have to make soil, which is the process in succession that takes the longest. In this case, the pioneer species are going to be small, hardy plants like grasses and weeds instead of lichen and moss. What makes grass and weeds really good pioneer species is that they can tolerate a lot of sunlight. And if all of the vegetation has been removed, there's not going to be a lot of shade available in this ecosystem. So it has to be able to tolerate a lot of sunlight, also has to be able to tolerate wide varieties in temperature, because the difference between day and night obviously will be big because again, there's no shade, and fluctuating soil moisture. Again, the lack of shade means that a lot of moisture is going to get pulled out of the soil during the day, and then obviously a lot's going to get put into the soil when it rains or something. And then these grasses and weeds will eventually pave the way for other plant species to move in. So after you have the grasses and weeds, when they grow tall enough, they'll actually start to create some shade on the soil. So the soil will start to retain more of its moisture because it's shaded. It's not going to have as high of levels of evaporation. It's also going to maintain lower temperatures in the soil because of the shade. And so as that happens, the soil is going to be able to support more other plants. Its fertility increases. And so once that happens, then some smaller shrubs can also move into the area. And as the grasses and weeds that were there die off, again, that gives more nutrients to the soil, which just further increases its fertility. So if we're kind of looking at the stages of succession, with primary succession, we start with the pioneer species of lichen and moss that will start the soil formation process. With secondary succession, you start with grasses and weeds as your pioneer species. And then if it's primary succession, the grasses and weeds will just be the first step in the sphere. And then regardless of what type of succession you're dealing with, after the grasses and weeds will come the shrubs, which can take anywhere from 6 to 25 years from the time the grasses move in to when the shrubs are able to move in. Those shrubs, just like the grasses and weeds prior to them, will further shade the soil, which will decrease the soil's temperature and increase the amount of water there. Then we get into what's sometimes referred to as the young forest stage, where you'll have some trees come in. Those trees can grow really, really rapidly. They'll need more water and more nutrients from the soil than the previous shrubs and grasses. But because the shrubs have been there shading the soil and the grasses and stuff have been dying, you now have that water and nutrient available to these trees. Spruce and birch trees make really good young forest trees, though they do tend, as most trees do, to outcompete shrubs and smaller plants for sunlight, which is going to cause those plants and shrubs to die off, which again just adds nutrients to the soil. Only shade-tolerant shrubs and mosses can live near the forest floor. And then the last stage is called the climax community, and that is the stable community that will remain in that ecosystem until there's another disturbance. The climax community is usually like mature trees, though again, some of them are going to get outcompeted, that sort of thing. So yeah, this is just kind of what it looks like. So you've got the pioneer species of lichen and moss, which come right after you've had a disturbance that brings you down to nothing but rock. So this would be where our primary succession starts. If you still have soil left after your disturbance, you would instead be starting with grasses and weeds right around here. So that's where secondary succession would start. And then after you move on from that, you get kind of the shrubs and then the young forest and then eventually the climax community. So the climax community is the end of succession then. It is stable. The plant species will be very well adapted to that habitat. The communities tend to have much higher levels of biomass and much higher levels of productivity than any of the other communities along the succession pathway. And the reason for that is that the dominant plant is really large trees. And large trees are heavy, and the heavier something is, the more biomass it has. So obviously a tree is going to have a lot more biomass than like a shrub. And then, oh yeah, productivity. So when we're talking about productivity, we're talking essentially about how much energy it has in it. And large trees have a lot of energy. Just think of like how much energy you could get from like burning down a tree compared to how much energy you would get from like burning a shrub, how much like heat energy you could get. So there's lots of energy, which is the productivity, and lots of biomass or weight in our climax community. They also tend to be fairly shade tolerant because they have to be able to handle, as they're growing, being in the shade of larger, more mature trees. As succession is occurring, all the different habitats and niches in the ecosystem are also changing. So that means that as we go through this process of succession, it's not just the plant communities that are changing. all of the animals and insects and stuff like that will also change based on what types of animals are suited to that habitat. Obviously, a grass habitat is going to support different plants and animals than, or sorry, different animals, I should say, than one that's made just of lichen or one that is a mature forest. As animals kind of come and go, as this ecosystem is changing, they will also contribute to some of the changes, whether it be dispersing seeds or providing fertilizer to the soil, stuff like that. So as succession ends, the ecosystem will stabilize, and at that point, the niches that are in that climax community will stay the same, and the animals that are in that in those niches should also stay the same. Because of that, you do get a decrease in biodiversity when you reach the climax community. You don't have a wide variety of plant life that you did when you were kind of in the young forest stage and even the shrub stage, because you now have these dominant tree species that can outcompete a lot of the other plant species in the area, and you're not going to have this constant transitioning of different species coming into and out of the area. So yeah, you do tend to have lower biodiversity in the climax community, which is why we don't really want an ecosystem to stay in the climax community forever. We want there to be natural disturbances that push a climax community out of stability back into one of the earlier parts of the succession pathway so that we can bump up the biodiversity again. Okay, so these are kind of the general rules of succession. 1, it's triggered by a disturbance of some sort. 2, it follows a general pattern of going from smaller species that keep getting replaced by larger and larger species, like the moss going to the grass, going to the shrubs, going to the smaller trees, going to the bigger trees. The number of species or the biodiversity will increase following the pioneer species, kind of level off in the middle and then drop back down with the climax community. Net productivity and biomass both increase the entire time until you get to the climax community, and then it will stabilize. And most plant communities are made up of different areas that are in different stages of succession. So if you look at a large habitat, like a forest, that entire forest isn't going to be at the same stage of succession. You might have one area that was like hit by a forest fire. You might have another area where there was some logging or something like that. You might have another area that had like a pine beetle infestation. You can have these different disturbances happen within the larger habitat that can result in different parts of that habitat being at different places in the succession pathway. Okay, so just to define some of these terms we've been talking about, net productivity is the amount of usable energy produced by the plants. So that could be what is stored within them that consumers could use or that we could use if we burn it, something like that. Biomass is the total mass of the living thing. And yeah, that's it. And we've already talked about biodiversity before, which is again, just the number of different species. Okay, I hope you enjoyed this unit. There's not going to be a quiz in this year because we just don't have time. So we'll do the unit test and then that'll be it.